Alright guys, here's the basic internals of a 760. As you can imagine, there's the sear, that little metal hook right there going into the tube. And the valve is right around here. And the end of the clamshell is right around here. As you can see, I have it marked off. So the basic gist of what I'm doing initially, I'm not going to keep it like this, but just for tuning, is if you see this part, it's threaded. And the front of it has a nylon seal, and so I'm going to chop the tube, threaded M17. This is going to go in and press that seal up against the valve. Now that valve I've already set aside, it's heavily modified for this purpose. This will press up against the face of the valve and create a seal, and this way we're not pressurizing the tube to very high pressure. If there is a catastrophic failure, it'll be at the joint of the valve, and because this is pressing up against it, you know, with a couple 100 pounds of force, it's threaded into steel, it won't be able to explosively discharge forward. In the backwards position it still could, but I'm going to pin the rear of the valve. So basically it's going to be catastrophic failure proof to an extent, but at least the mechanism or manner in which it fails will be predictable. And then on this end of the hose will just be a fill nipple, and so it'll be quick to get up and running without building an air tube and all that type of design implementation. You know, to get up, get some test results. One of the challenges will be upgrading the hammer spring and still cocking it with this little, you know, with this little plastic handle. We'll hope that works out, but it's going to need probably a little more hammer energy. But everything else, you know, as far as the probe, the barrel, everything's sorted out for me. I just need to funnel the pressure into the valve, and this is the most effective way to do it, where it would handle higher pressure. Now I've done this arrangement before at 2,000, 2,500 psi. I've never done anything above 3,000 psi in a 760. And specifically, the problem is, if you guys will hold on 1 second, and I'll show you the where the weakness is in this valve we're going. The weakness of a 760, this is a new style 1377 valve, but they're, you know, more or less identical. I haven't taken the valve out of the 760 yet. Alright, I'm going to need to unthread this, so I need 2 hands. Give me 1 second. Alright, that was probably 5 seconds, but anyway. Where this O-ring sits to seal the 2 halves is the weakest point. The wall thickness gets down to about 40 thousandths. So like this portion of the valve, if otherwise, you know, not impeded by any other weakness, would handle substantial pressure, and so would this side of the valve, but the connection point. So in this scenario, let's pretend they're connected again. We have, you know, a compounding factor that this seal, this nylon seal, is pressed up against here by threading into the steel tube. So all the net force is rearward. So that's the only thing we'll have to compensate for, is that rearward pressure. In the event there's a valve separation, we don't want that valve to eject out the rear of the tube. And I'm pretty sure there's a crimp in the tube to prevent that, in the underside of the tube. I have to check, but either way I'm going to do some pinning to be more certain of it. And that's pretty much it. That's the game plan for the initial setup, is basically what you're seeing would be happening inside the tube. Now you might be wondering, well, why is the O-ring removed from the front of the valve? Well, there's actually no sealing to the tube, and I'd actually prefer there not to be, because if there's a breach right here, I don't want that net pressure all acting on the valve. The key here is the connection is small in diameter, and the diameter or the area of the circle determines the force. So if we're at, let's say, 4,000 psi, you'd much rather have that 4,000 psi acting on a 375 diameter like this seal than the total 750 diameter, or not 750, 625 diameter of the valve. So it's all about, you know, mitigation, and how do you reduce risk, how do you reduce high stress areas and stuff like that. And you know, we'll see how this goes. It might not work right off the bat. I might just get valve lock above 2,000, which is a strong possibility. But I'm going to try to upgrade the hammer spring before I even put it back together. But anyway, more to come. This and another interesting project are coming up soon. Thanks for watching.